Good evening, guys. Welcome to today's session. So we know we are doing domain analytics, sponsored by 360DigiTMG regarding robotics, right? So we have seen KNN, we have seen linear regression, decision tree, neural networks, and we have seen what is the agenda, how to clean the data in all the videos, right? So in the last sessions, we have seen how we are going to implement the KNN. Okay. So in today's session, we are going to see how we are going to implement K-means algorithm. Okay, so how we are going to implement K-means algorithm in robotic analytics. Okay, so what is this K-means clustering? So before going that, so in case if you have missed any classes of this robotics analytics, you can always watch the recorded videos in the YouTube channel 360DigiTMG. Okay, so today's session we are going to see how we are going to implement robotic analytics in unsupervised learning. That is nothing but K-means clustering. So what is meant by K-means clustering? Right, the concept, what is behind this K-means clustering concept? Okay, so what is this K-means clustering mean? So K-means clustering is a method used for clustering analysis, especially in data mining and statistics. Okay, so K-means clustering is nothing but, guys, is a method. It is used for clustering analysis and especially in, like, let me say, like a data mining and statistics. Okay, it basically aims in partitions of a set in the observation integer number. The clusters may result in K. Okay, so K-means clustering is nothing but, guys, is a method used for clustering analysis, especially in data mining and statistics. Okay, resulting in the partitioning of data into sets. So how this K-means clustering is going to work? So K-means is a centroid-based clustering algorithm. Okay, it is a, like, let me circle here. It is a centroid. Okay, K-means is a centroid-based clustering algorithm where we calculate the distance between each data point and centroid to assign into a cluster. Okay, so K-means clustering, how it's going to work means it is a centroid-based clustering algorithm. Okay, where we can calculate the distance between each data point and centroid to assign to a cluster. The main goal of this K-means clustering is to identify the K number of groups in a data set. Okay, so what is the example of K-means clustering? If you're going to ask me what is the example for K-means clustering, so let me say the K-means clustering basically generate groups comprising the observation with similar characteristics. Like example, if you have a customer of data, if you have a customer data, you might want to create sets of similar customers and then target each with different types of market. Okay, for example, if you have a customer data and you might want to create a sets of similar customers and then target each group with different type of market. Okay, so K-means clustering is a popular machine learning algorithm also, guys. Okay, it is a very important machine learning algorithm. So how this K-means clustering is going to use in our real life means real life examples. If you want to ask me, it includes spam detection, sentiment analysis, scorecard prediction of exams. Okay, so basically the real time example using this K-means, I can say sentiment analysis, scorecard prediction of exams, and all. Okay, so how do you why it is called as K-means? The question may arise, why it is called as K-means? So in the other word, the K-means algorithm identifies K number of centroids. Okay, it basically identified K number of centroids, and then it allocates every data point to the nearest cluster. Okay, let me say, while keeping the centroids as small as possible, the mean is the K, and it's going to refers to averaging data, and we're going to find the centroid. Okay. Basically, we're going to find the centroid using this K-means clustering. Okay, so I assume that is clear. So moving on, guys, we're going to see what is the CRISP MLQ. Okay, so in the sessions we have seen what is meant by CRISP MLQ, right? So CRISP MLQ is nothing but cross-industry standard process for machine learning quality assurance. Okay, that is a full form of CRISP MLQ. It's nothing but a cross-industry standard process for machine learning quality assurance. Okay, so this is what is meant by CRISP MLQ, guys. And the project management methodology, there are 6 steps. Okay, Project management methodology is nothing but a standard form to complete a project. To complete a project in standard form, we have 6 terminologies should be used. Okay, we should follow this. The first one is business and data understanding. The next one is data preparation, and we have model building and tuning, model evaluation, deployment, monitoring, and maintenance. So, guys, what do you understand by business and data understanding? So basically, we're going to collect the data. First, when we get the data, we're going to understand the data. So what has to be done? So should we do data EDA? Should we clean the data? Okay. First, we're going to get the data and we're going to understand what is going to happen. And after that, data preparation. Okay. Data engineering. We're going to do something. Okay. Let me show you. So what are the steps are involved? Okay. So I'm going to show you the mind map of 360DigiTMG. We can follow that, guys, if you want a good knowledge about that. Okay, so let me show you the mind map. So okay, this is the mind map of 360DigiTMG, guys, regarding data science. So as I was saying, the crisp MLQ, you can see business understanding. Okay, so in business understanding, what we have to do. So in the data you can see. So let me show you. So you can see here, where the second slide, right? So you can see business and data understanding. Okay, and we have data preparation, model building, and tuning. The same thing is available in the mind map, guys, which keeps on updating every day. Okay, you can follow this if you want a good knowledge about data science. Okay, so when I said about business understand, so we're going to see what all the things should be happening. We're going to record business objective. We're going to record business constraint. We're going to see what is the success criteria if we apply this method, and we're going to use a terminology where we should use it is recommended to write objectives and constraint using 2 or 3 words. Okay, and we have to use the optimization words. So optimization terms are nothing but, guys, minimize and maximize. Okay, and we have project charter. Project charter is nothing but let me say first document to get signed, and it has highly confidential details. Okay, so when you click on that, you can see it, guys. This is the first document which gets prepared on any project, contains highly efficient details, and we have document is signed by project sponsor. And the success criteria, if you're gonna ask, we have what is the business success criteria and what we are going to get in it. What is the method we should apply to get a success criteria? Is it low? Is it high? Is it intermediate? Okay, so these are the things we should follow in business understanding, guys. Okay, and the next one we have is data understanding and data preparation, right? So what is meant by data understanding? So basically we are going to understand what our data types. Okay, is our data continuous, discrete, qualitative or quantitative, semi-structured, or it's a big data or balanced data? Okay, so we're going to see what is our data types and data collection. We are going to see, is it a primary data source or secondary data source? So what is meant by this primary data source? Primary data source, guys, which you get it by the license term. So let me give an example. So secondary data source means which is collected before the hand is primary data source, which is collected through the net is secondary data sources. Okay, so primary data source contains every details of any module, you can say, of any software. Secondary data source, we can get there will be missing of some files, guys. Okay, in simple terms, let me say a game. Okay, so if you get a license of any game, okay, let me say any game like any game. If you get a license of that, that is a primary data source, because if you get a license, everything will be included there. There will be no missing of the data because you have purchased them. Okay, and data collection is secondary data source is nothing but where you collect it from the internet. Okay, from the net is nothing but there will be missing of some data. Okay, the game may crash, right? So that is called a secondary data source. But there is advantage and disadvantage here, guys. In primary data source, the cost is high. Okay, you're going to buy the license, the cost is high, and the time is also high. In secondary data source, there is no cost. You're going to download it for free from the net if it is available. Okay, and there is a time consuming. There is no less time consuming because you're going to search on the internet and you're going to get it. Okay, so this is a difference between primary data source and secondary data source. Okay, and the remaining words we can see it while applying the practical terms. And moving on, we're going to go for data preparation. Okay, we're going to see what is meant by data cleansing. So after we understand the data, after we know what these data types and all, we're going to go for data cleansing. Okay, we are going to see what we should do with data. So what is this typecasting? Typecasting is nothing but, guys, converting one data type to another data type, like integer to float. So why do you have to convert that? So when you click on typecasting, guys, you can see converting one data type to another data type. Okay, handling duplicates. If the columns are same, so do we need the data? So the same thing we have. Okay, and how to, what is the code for that? We have data.duplicated, data.drop duplicates and everything. Okay, how to handle duplicates? We have seen that. And outlier analysis statement, guys, is nothing but let me say there is a graph. Okay, there is some data points. If one data is far from here, it is called as an outlier, guys. Okay, which has some extreme value. See, the data points are here, but the data point is here, which has some extreme values. Okay, in the table, for your better understanding, let me say there is 1, 2, 3, 4, 5, and 100. This is called as an outlier, guys, because 1, 2, 3, 4, 5 are nearer, but 100 is an extreme outlier. Okay, it is an extreme value. That is called as an outlier. So how to solve this value? How to solve this? We have some techniques, which is called as visualization, masking, swamping, and trimming. Okay, so we are going to use visualization. Okay, the one of the best thing is visualization, where we are going to use. So when you click on visualization, you can see this technique modify the sample distribution of random variables by removing outliers. Means it's gonna use a technique which basically modifies to remove the outliers. Okay, and you can see 90% visualization means all data below 5th percentile is set to 5th percentile, and all data above 95th percentile is 95th percentile. Okay, that means whatever the data 90% of visualization, the data will be below 5th. Okay, and what is all about 90th percentile, it is set to 90%. Okay, and we have small swamping, masking, trimming, and all, guys. So in the latest sessions, I have been explained about that. Okay, if in case if you have missed any classes, you can always watch it in the recorded videos. Okay, so zero and non-zero variance. So what is a zero and non-zero variance is all about? So guys, basically I have explained you all things about in the recent classes. Okay, so for what is important for k-means clustering, I'm going to go with that. Okay, so zero and non-zero variance, usually we ignore the columns with the same entry throughout. Majority of the entries are same. So let me say there is a two column, okay, which contains 0, 0, 0, 0 and 0, 0, 0, the same table. So let me draw it and show for you. So there is a two table which contains 0, 0, 0, 0 and 0, 0, and this table is also same. Okay, this table is also same, containing same values, containing same rows, containing same columns. Do we need this, guys? Both are same. If we delete one, it can save our data, the storage can be saved, and the computation will be high, right? So basically the same thing in zero and non-zero variance. We're going to ignore the entries, which is throughout the majorities. Okay, and missing values. Okay, what is missing values? The terminology missing value, the name itself indicates missing values. So there is some value. So here I said we have 0, 0, 0. Sorry, let me go with the terminology numbers. Okay, so we have 1, 2, 3, 3, 2, 1, 0, null, and blank. So guys, missing values where there is no values, okay, that is called as missing values. Okay, to solve that, we are going to use imputation. Okay, and we have some techniques for that. So deletion methods, single imputation methods, model based methods. Okay, so we have different type of imputations, guys. And clicking on discretization, it is nothing but converting continuous data to discrete data. Okay, we have binarization, rounding, and binning. Okay, how we are going to convert this continuous to discrete data? So the name itself says discretization, guys. It's nothing but where it is going to convert continuous data to discrete data. Okay, and binarization, rounding, and binning. So I have explained, guys. Only regarding k-means clustering, we are going to explain today. Okay, so dummy variable creation. So one-not encoding, label encoding. These are very important, guys. One-not encoding and label encoding. So one-not encoding basically says when you and the project sponsor only you have to know the details, we can go for one-not encoding. Okay, when you click on one-not encoding, you can see where in which libraries we want to get it. Okay, from SQL under processing, import one-not encoding. Okay, that is the library which is used to import one-not encoding, guys. Okay, and remaining guys, so this is the best pre-version best where you can understand data science very easily. Okay, every time go through the data science mind map. So always the 360DigiTMG is gonna keep on update what is best in the market. Okay, they're gonna give always the details which the students can gather all the information without any lag behind. Okay, so be getting all the details guys whenever thing is updated, wherever it is updated in data science, it always get updated in this my data science mind map. Okay, so after that we're going to go for transformation. The name itself indicates transformation. So what is transformation? Is transforming the data. Okay, we're going to check for normal distribution, we're going to see log, uh, exponential, square root, reciprocal, and all. Okay. Standardization, normalization is nothing but guys, we're going to make data scaleless and unit free. Okay, you can see it will make the data scale free and unitless. Okay, so these are things guys which are very important for chemistry history. And string manipulation is nothing but we have token. This is all NLP concept guys. Okay, so we have tokenization, stemming, stopword removal. Okay, so let me explain you about tokenization. So tokenization is nothing but guys where it converts sentences to words. Okay, it breaks down sentences, okay, to words. Okay, it's going to break down sentences to words guys. And the next thing we're going to go is for stemming and lemmatization. So what is the difference between stemming and lemmatization? Stemming and lemmatization. So what is stemming? So guys, it's going to reduce the infected words to their base form. Okay, it's going to reduce the infected word to their base form. Their base form in the sense guys. So let me say there is a terminology called history and history and story. Okay, so the stemming words guys doesn't follow dictionary words. It's gonna give it the value of its own base form. So it's gonna give you history. Okay, we know history spelling is this. So basically stemming is gonna reduce the infected words, but it's gonna give the base form of its own. It doesn't follow any dictionary word. And lemmatization guys, okay, it is gonna reduce the infected words. Okay, this lemmatization is gonna reduce the infected words, but it gives the correct form. Means it's gonna follow the dictionary of words. Dictionary words. Okay, means here we know the history is a perfect word, but stemming has given it to their base form. But lemmatization, it's gonna give the perfect dictionary form. Okay, it's gonna give history itself. Okay, so this is the difference between stemming and lemmatization, guys. Okay, so I assume that is clear. It's meant by tokenization, stemming, or lemmatization. Okay, and after that we are gonna go for stopword removal. Basically, it remove the words ing guys. So let me say, you can say here it is organizing. Okay, organizing. The stopword removal is going to remove ing guys. Okay, it's going to remove ing and it's going to give organize. Okay, this is what is meant by stopword removal guys in the basic sense. Okay, so remaining we are going to see as we move on to the topics. So, and next we have is exploratory data analysis. So what is meant by EDA? Where we have 4-moment business decision guys. So whenever they ask what is a 4-moment business decision, you can always say there are 4-moment business decision. That is first moment, measure of central tendency, measure of dispersion, measure of skewness, and kurtosis. Okay. So guys, we basically have 4-moment business decision. Okay. First, let us go with the first one. We have measure of central tendency, as I said. So what is measure of central tendency? It basically has mean, median, and mode. It's basically has mean, median, and mode. This is the first moment business decision, guys. As I don't want to go deep because we have seen the sessions. Okay, that I'm going to explain you basic things. So second moment decision is called as measure of dispersion. In that we have variance, standard deviation, and rate. Okay, and in third moment business decision, we're going to have skewness. So if skewness is 0, then it is normally distributed. This is very important topic. Okay, when the skewness is 0, the skewness is 0, then it is normally distributed. Okay. So when it is normally distributed means the skewness is 0, then only it is normally distributed. What is the positive skewness called? It is right skew. If negative, it is left skew. Okay. And the fourth moment based decision, guys. We have seen kurtosis. Okay. So in skewness, when it is 0, then it is normally distributed in skewness, right? But in kurtosis, if kurtosis is equal to 3, then it is normally distributed. Okay. And negative kurtosis is called as platykurtic, and positive kurtosis is called as leptokurtic. Okay. So you have to remember this terminology, guys. What is meant by leptokurtic and platykurtic? Okay. So in skewness, we have seen if it is 0, then it is normally distributed. But in kurtosis, when it is 3, then it is normally distributed. Okay. So moving on, guys, we're going to see for model building. Okay. Supervised learning and unsupervised learning. So today's topic was all about K-means clustering, nothing but unsupervised learning, right? So difference between these both supervised learning and unsupervised learning is, guys, supervised learning is going to give both input and output. Okay. And unsupervised learning is going to only give us the output. Okay. And clustering and segmentation. Okay. Hierarchical clustering, guys. So we have hierarchical clustering, partition-based clustering, drill-based evaluation techniques. Okay, so when you click on hierarchical clustering, you're going to see there are two types, guys: agglomerative clustering and divisive clustering, bottom to top approach and top to bottom approach. Okay, when you click on agglomerative clustering, it is called as bottom to top approach, guys. Means in the sense, what it's going to explain means bottom to top. Okay, there is one cluster. Okay, and it's going to go on with like this. So let me say bottom to top approach. Okay, it's like bottom to top approach. Where from a lower side it goes like this. Okay, like bottom to top approach. And it's always starts with single clusters, continuously merge with two clusters, and it's keep on build. Okay, and how to visualize this hierarchy cluster? We are going to use dendrogram. We are going to visualize using dendrogram. Okay, so what are type of clustering techniques we have? We have a balanced iterative reducing clustering using hierarchies, nothing but burst, guys. We have queued clustering using representatives. Okay, so these are very important type of codes. And if you want to ask me a code, how to write a Python code for that, you can see what are the packages we need to import that. SciPy.cluster.hierarchy. Okay, so what are the functions of that? We have linkage and dendrogram. Okay, so guys, I recommend you to always watch the videos of 360DigiTMG and go to the mind maps as it is keep on updating every day, right? So you'll get a good knowledge about data science using this data science mind map. Okay, when you're going to learn this, you're going to open this and read it for 5 minutes. I guarantee you, so you'll get an idea of all the terminologies. Okay. So clustering is done, guys. Dimension reduction. So basically, guys, what is this dimension reduction? It's basically reduce the dimensions. Okay, in the simple words. Reduce number of columns. Yes, that is also a perfect word. So we have LDA, ICA, SVD, PCA. So we have seen, right, what is meant by principal component analysis, singular value decomposition, nothing but SVD, independent component analysis, ICA. When you click on principal component analysis, guys, you can see the explanation about that, where it is used to convert large number of features into fewer features with some loss of information. So it's going to convert a large number of features into fewer features. So let me say have 1 MB of photo. Okay, when you're going to use some application like trimming of the photo, it's going to convert your photo into small, but there are loss of information when the loss of data. The same thing is going to happen in PCA also. Okay, and it is also called as feature extraction, not feature selection. Okay, I think it will be somewhere here. Okay, you can see here it is called as feature extraction, not a feature selection. Okay, and if you go for SVD, nothing but single value decomposition, we are gonna see what are the applications. So recommendation engine, guys. So the term says recommendation engine. So guys, I believe so. Whenever you go to an Amazon or Flipkart, when you click on the thing what you need, it's always shows you recommendation, right? So you're gonna buy some watches, like let me say a watch of Fast Track. It's always recommended different products, companies also. Let me say OnePlus, Apple, and all right. So that is called as recommendation engine. Okay, so this was all about the elevation reduction, guys. So I'm not going to go deep here because we have already seen this. Okay, so we're going to see what is meant by supervised learning, right? So we have seen this predictive modeling. We have some type of classification models. So as we are going to do with unsupervised learning, so we're going to focus more on that. Okay, and we're going to do what is meant by evaluation. So accuracy. Okay, when y is continuous, we have so many things, guys. We have seen, right? Root mean squared error, mean error, mean percentage error, mean absolute percentage error, right? And we have discrete, where we have confusion matrix, cross table. Okay, guys. So what is error function is also called as error function is also called as cost function or loss function. Okay. What is meant by model deployment? So guys, whenever we create a model, we are going to deploy it, right? So deployment of the model is called as model deployment. So after deploying, we're gonna monitoring and maintain it. Okay, we're gonna maintain the model. So this was all about the mind map, guys, which is for supervised learning, unsupervised learning. So we're gonna get back to the slide, and we can see the next thing is what is meant by unsupervised learning. So unsupervised learning is a technique, is a machine learning technique, guys, which models are not unsupervised learning using a training data set. Okay. So what is meant by unsupervised learning is a machine learning technique in which models are not supervised using a training data set. Okay. Instead, the models themselves find the hidden patterns. Okay. This is the one important thing about this unsupervised learning, guys, where we don't have, it's going to learn the technique and it themselves find a hidden patterns and insights from the given data. Okay, it can be compared to learning which takes place in human brain. Okay, so and the goal of unsupervised learning. So some questions may arise, sir, what is the goal of this? So as they're gonna learn themselves and it's gonna find hidden patterns and insights. What is the goal of this unsupervised learning? The goal of this unsupervised learning is to find the underlying structure of the data set. Okay, and it's gonna represent data set in compressed format. The resultant groups clusters will have a low variance. Okay, so moving on, we're going to see how this unsupervised learning is going to work. So unsupervised learning, we have k-means clustering, KNN. So these are the some popular list of algorithms. We have k-means clustering, we have KNN, we have hierarchical clustering, anomaly detection, neural networks, PCA, ICA, and we have a priori algorithm. We have SVD, single value decomposition. So guys, in KNN, I have explained you about this. Okay. So we're gonna see what is meant by this unsupervised learning. Okay. So you can see there is a raw data. Okay. The image itself shows there is cats and dogs, right? So how to use unsupervised learning and how to do a classification, okay, of this. So we are gonna use some processing. Okay, we are gonna use some algorithm where you are gonna separate cats and dogs separate in the classification. You can see after applying interpretation algorithms of unsupervised learning algorithm, we have seen the output. So here the input raw data, it was raw data, all was in one field. So after applying unsupervised learning, we can see there's a difference. There is a different classification of cats and dogs. Okay. So moving on, we are going to see how this unsupervised learning is going to work. Okay. So what is unlabeled data and labeled data? So unlabeled data. Okay, here you can see there is unlabeled data. After applying k-means cluster. Okay. So we are going to go with labeled data. So you can see the centroid is here is X. Okay. So after that, we are going to see what is meant by k-means clustering. As we are going to apply on k-means clustering, we are going to see what is meant by k-means clustering. So k-means clustering. K-means is one of such unsupervised learning methods that aims to group similar data points in clusters. Okay, it's basically going to use unsupervised learning method and it's going to aim for similar group of clusters. It is a centroid based algorithm. So we have seen this. It is a centroid based algorithm where each cluster is associated with a centroid. Okay, we know this, right? So I have explained you some examples too. So the main aim of this algorithm is to minimize sum of distance between data point and their corresponding clusters. So what is the main aim? The main aim of this K-means clustering is to minimize sum of distance between data point and their corresponding clusters. Okay. So we are going to see what are the steps involved. So the goal is to minimize the distance between the data points and their corresponding clusters. Okay. So what are the steps are involved? This K-means clustering. Solve that problem. So we're going to initialize centroids K. For each sample in the set of samples, we're going to assign sample to its closest cluster. Okay, based on Euclidean distance. So what is this Euclidean distance, guys? Is nothing but between centroid value and observed value. Okay, the Euclidean distance is nothing but where it is called as between centroid value and observed value. Where we can follow the goal of this K-means clustering. We're going to find the sum of distance between data point and their corresponding clusters. Okay, and for each cluster in the data set, in the set of clusters, we're going to recalculate the cluster of centroid. Okay, we're going to recalculate center of centroid based on the simple cluster. Okay, that is our main aim here, guys. Okay, we're going to use Euclidean distance. We're going to calculate. Okay, so after that, we're going to see what are the things which is important to us. Okay, so moving on, we're going to see what are the terminology. Okay, so moving on, guys, we're going to see what are the other steps involved in K-means clustering. So other steps in K-means clustering we have is we're going to repeat the steps 2 times or 3 times until the criterion is fulfilled. Okay, we're going to follow that step until that is giving us the criteria that is fulfilled. Okay, and after that we are going to go for determining the variance of each cluster. Okay, we're going to determine the variance of each cluster. Okay, and we're going to repeat the steps 1 to 5 different types. Okay, we're going to repeat the steps which is important to us. Okay, so after that we're going to see what is the importance. The next step, we're going to determine the variance of each cluster, that is nothing but SSE. Okay, and we're going to repeat the steps 1 to 5 times, and we're going to initialize the cluster of centroid positions. Okay, so moving on, guys, what is the advantage of this K-means clustering? So advantage of K-means clustering, guys. The K-means clustering algorithm is used to group unlabeled data into clusters and similar attributes. Okay, in a scale of well large data, it's an appropriate method when you know the number of clusters can be drawn in data. The speed of this is very an advantage of K-means clustering, guys. Okay, so we're going to see what are the limitations. Okay, so limitation of K-means clustering is, guys, number of clusters must be chosen from upfront. Okay, outliers can have a strong influence on results. Initial centroid positions have a strong influence on results. These clusters will have clusters with varying sizes and densities. Okay, number of clusters must be chosen upfront. The main thing. Okay, we're going to see what is the key concept of K-means clustering. So what is the key concept of K-means clustering is, guys, you can see the K-means clustering multiple times is called as iteration with different randomly chosen K values. Okay, it is called as local minimum values. And we are going to compare between cluster variation to within cluster variation. We're going to see SSE in sum of squared errors in typical objective function. We're going to see a data point might be oscillating between 2 clusters. In each of the runs and algorithm will have infinite loop. Okay, convergence criteria is to stop when a cluster centroid moves less than a percentage, and the distance of that, and there's a smaller distance between centroids. So these are the key concepts of clustering, guys. Okay, so use cases we are going to see, and this is the graph, elbow graph we have, guys, on the clustering part. So we're going to go for the coding part now. Okay, so in the coding part, we're going to see how we are going to implement this K-means. Okay, the concept here is, guys, about this K-means clustering is there. As we know, it's a classification. We're going to see this K-means clustering, how the robot is going to identify the numbers. Okay, here you can see in this project, we'll use K-means algorithm to perform image classification. Okay, I have written everything, guys, so you can learn it very easily and understand it very easily. Okay, in this project, we'll use a K-means algorithm to perform image classification. Clustering isn't limited to the consumer information. Okay, in this project, this thing you're gonna learn pre-processing of clustering, how to deploy K-means, okay, and how to visualize high-dimensional cluster centroids. Okay, so what is this SYS, SQL, and Matplotlib, guys? You know that it's a libraries, right? We are gonna import libraries. Okay, so we're gonna import library SYS, and we are gonna import library SQL, and we have imported Matplotlib is nothing but advanced data visual for graphical representation, guys. Okay, so importing. So what is this import SYS? This is nothing but a Python SYS model, guys, which provides functions and variables. Okay, basically I can say which are used to manipulate different parts of Python runtime environment. Okay, it is basically let us to check the access system and the specific parameters and functions. So this import SYS is, guys, we have to import this SYS model in our program before running any function. Okay, before running any function. Okay, that is the use of this SYS, guys, and have imported sklearn. We know what is meant by sklearn, right? Scientific calculator means it's for visualization. Okay, data matplotlib is for visualization, and sklearn, guys. So what is sklearn in Python is nothing but it is probably the most useful library for machine learning in Python. Okay, it is best and useful library for machine learning in Python, and matplotlib, as I said, it is for representation, graphical representation, and NumPy is a basic calculator as NP. Okay, and I'm going to print in the format SYSS version and have took this code. I have printed everything till NumPy, skill, and the libraries which I have given. And you can see the versions which I have used, right? The Python 2.7.13, this is my version, and sklearn is my version, and Matplotlib version is 2.1.0. Okay, and I'm going to import the MINS dataset. Okay, so after importing MINS dataset, I'm going to go with from Keras, I'm going to go with dataset to import MIST. Okay, so here I'm going to train, I'm going to do training in the form of XTrain and XTest. Okay, I'm going to train my model. Okay, I'm going to train my XTest and YTrain and YTest. Okay, so you can see what is the accuracy we have got. So in training data, we have got this much, and testing data, we have got this much. Okay, and after that, I'm going to import matplotlib as .plt. Okay, so one more time, here you can see we have imported only matplotlib. Okay, here I'm going to import matplotlib as plt for graphical representation. Okay, that is nothing but I have written you guys. So it's a Python magic function. Okay, the percentile of matplotlib in line. So after importing that, you can see what are the loop through subplots and builds images. So I'm going to give a flat and train, and I'm going to off the axis. You can see, guys, you can see the numbers is 5. So basically, the machine is going to recognize, guys. So I have trained my model, I have trained my robot in such a way that so it should let me say it should classify the numbers. Okay, you can see here number 5 has been recognized by robot as number 5. Number 0 has been recognized as 0. Number 4 has recognized as 0. So basically, guys, I have trained my robotics model. Okay, I have trained my robotics model. It's going to give us the classification of numbers. Okay, so we know K-means clustering is classification. So it's going to give us the classification of the numbers. Okay, so when I scroll down, you can see I have a use of pre-processing techniques. Okay, so images are stored as numpy's array are in 2-dimensional arrays. So what is 2-dimensional arrays? Where we have 2-dimensional, the name itself indicates 2-dimensional arrays. Okay, and after that, the clustering algorithms will almost use 1-dimensional data. Okay, and we're going to use 3-dimensional data. For example, 3-dimensional data is nothing but, guys, where we have 3 images. So you can see here 2-dimensional, guys, we have 2, 4, and 3-dimensional data is nothing but we have 3 dimensions, the length of 3. Okay, so after pre-processing the images, so we know what is the steps involved in pre-processing, right? So I'm going to convert each image to 1-dimensional. Okay, so we have seen what is meant by 2-dimensional. The 2-dimensional array is nothing but length of 2, and 3-dimensional is nothing but length of 3. So I'm going to convert each image into 1-dimensional array. For that, I have written a code x underscore train dot reshape. I'm going to reshape the length of train to -1. Okay, so why am I doing that? This is a pre-processing technique, guys, where I'm going to reduce the length, three-dimensional array, two-dimensional array. I'm going to reduce the length, and I'm going to reshape it to length of 1. And after that, I'm going to normalize the data. Okay, I'm going to normalize the data x dot x type, and I'm going to print x shape and everything. Okay, after that, I'm going to go for k-means clustering. So what is meant by k-means clustering? We have seen it. So this is a time where we're going to start our clustering, guys. So the concept is, we know we are going to do image classification, where I'm going to train my robot to identify the images on the classification words, the numbers. If it is 0, it should cost me as a 0. Okay. From SKL100 cluster, I'm going to import mini batch k-means. Okay, I'm going to import the k-means, and after that, I'm going to give the length as np.unique, and I'm going to initialize k-means model. Okay, where I'm going to initialize k-means model using this mini batch k-means. After importing that, guys, I'm going to fit the model in training data. Okay, I'm going to fit the model in training data where k-means dot fit dot x. Okay, so the mini k batch means is going to give me the batch size of 100, compute labels as true, and the initial size and the reassignment ratio, verbose, and everything. So after that, I'm going to use assigning cluster labels. So in k-means clustering, guys, it is an unsupervised machine learning method. Basically, let me say this assigning cluster labels is nothing but, guys, it refers to cluster each arrays in way assigned to. Okay. Basically, I can't say not on the actual target integer. It's basically on predicting the integer with corresponding things. I think, okay, I have written it here, guys. You can see k-means clustering is an unsupervised learning method. Consequently, the labels assigned by our k-means algorithm refer to clusters each array was assigned to, not the actual target integer. It's going to fix this. Let's define a few functions that will predict the integer corresponding to each cluster. So I'm going to predict the cluster. So I'm going to use DEF, and I'm going to write some code for integer of k-means clusters. I'm going to find the index of each clusters using these labels, and I'm going to append the actual labels. Okay. And I'm going to assign the clusters. I'm going to create a new array. Okay. After that, I'm going to go with the inferred labels. Okay. So after doing that, guys, you can see the code. You can see the code what we have got, right? So inferior labels we have got, and inferior label function also we have got. Okay. And we're going to see optimizing and evaluating the clustering algorithm. Okay. I'm gonna go with optimizing and evaluating cluster algorithm. Okay. So with the function of the defined above, we can now determine the accuracy of our algorithm. So we're going to determine what is our accuracy. Since we are using the clustering algorithm, we're going to see which is the accuracy which is important to us. Okay. So after that, I'm going to print the metrics of clusters. Okay. And the clusters, we're going to test different number of clusters. For n clusters in I clusters, we're going to see what is the determined labels. So how to print cluster metrics. So how to calculate the print accuracy, right? So these are the important things we're going to calculate using the clusters, guys. And after printing the cluster of metrics, and after determining the predicted labels, and after calculating the print accuracy, the number of clusters we have got is 10. And the inertia, the homogeneity, the accuracy, you can see, guys, we're going to maintain the accuracy. So it's going to increase the number of clusters increase. Okay. So you can see the number of clusters was 10. Okay. The number of clusters was 10, and the accuracy was 0.5909. When the accuracy of the cluster, when the clusters was increased to 16, the accuracy was increased to 0.650. And again, the clusters was 36, the accuracy was increased to 0.78. Okay. The same thing, guys, whenever I try to increase the cluster, the accuracy keeps on increasing, which is a good sign for us, right? It's going to classify the image. Okay. K-means cluster is for classification. So whenever I increase the clusters, it's going to increase and give me the accuracy more. So after the accuracy, I'm gonna test k-means algorithm on training dataset, and I'm gonna convert each image to one-dimensional array. Okay, and I'm gonna normalize the data. I'm gonna initially fit k-means algorithm on training data. I'm gonna keep the k-means of clusters of 256, and after applying the k-means, I'm gonna fit a model of X. Okay, where we know the data, what we are going to do it, and after that we're gonna visualizing the cluster centroids. Okay, the most important part, let me say the most representative part with each cluster is called a centroid. So we know it's going to go with the centroid, the clustering values. We can reshape this array back into 28 by 28 pixel image. Okay, we're going to initialize the k-means algorithm. Okay, so basically, you know the concept. We're going to find the classification of images. Okay, we're going to reshape the centroid images, and we're going to determine the labels, which is important, and we're going to go through loop through subplots. Okay, and we're going to determine, we're going to add image to the subplot. So these are the things which we are going to go for, guys. Okay, and one more thing is, guys, we're going to add image to the subplot. Okay, we're going to add image to the subplot. Okay, so after adding image to the subplot, we're going to see what is the important thing. Okay, what is the labels dictionary we have. Okay, so after adding the subplot, the image, you can see the robot was successfully able to identify the classification of image, guys. Okay, so the main aim of applying this k-means clustering is to the robot should find the classification of images. You can see inferred label 6. So it has been, you can see for 9, it has given the image of 9. For 1, it has given as 1, 0 as 0, and 2 as 2. So here our model was successfully uh, given the accuracy, guys, where it was able to find the models. So you can see the robot was able to find the 6. If I have given the number 6, it was able to see, recognize this as a 6 number. Okay, so this was all about k-means clustering, guys. So it's nothing but the k-means clustering, where we are gonna do image classification using robotics. Okay. So this robotics is very important, guys. So as we saw in all the 8 days, we have seen the k-means clustering, k in linear regression, decision tree, and the agenda, cleaning of data, and so on, right? So the k-means clustering, which is the method we have implemented, was perfectly used for the robotic self, guys, where it was given the image classification. Okay, where it gives us the image classification, you can see the robot, the module which we trained and tested, was able to predict the images. Okay, it was able to print the value which was important, which was given. Okay, when I say 2, it was going to print as 2. It's going to recognize and it's going to classify the images, guys. Okay, here you can see the classification of the images and the libraries what we have imported, right? The first thing you can see, the classification of images was our main goal, and it was able to classify the image. And the means data set we have used, we have imported the libraries, we have gone through the figure, and we have gone through the pre-processing time, we have gone through k-means clustering, we have gone to assessing, assigning these cluster labels. Okay, and we have gone through the optimization. Okay, and we have initialized that. Okay, so these are the main things, guys, in k-means clustering. So in case if you have missed any classes, you can always watch the recorded videos on domain analytics, which is sponsored by 360. Okay, so this is the end of the session, guys. Okay, thank you for attending the session. So we have completed the session of robotics in domain. Okay, thank you for attending, guys.